Okay, we are going to start with lesson 8, session 1, and we're actually going to do part of session 2 as well. We're going to combine both today. Begins on page 169, and we're going to work through pages all the way back to 177, 178, but not doing every single page, obviously, just going through some different problems together and skipping around. So lesson 7, we were looking at work with decimals, addition, subtraction, and multiplication. Well, lesson 8, we're going to start with division. Session 1 is whole numbers, and although in 6th grade you have to be able to divide decimals, I think we need to take a few minutes and actually work on dividing just regular whole numbers. So this is something from 5th grade you probably did, but again, it's been a while, so we're going to review for session 1. So again, we're on page 169, lesson 8, session 1. Previously, you used area models and partial quotients to divide. In this lesson, you will learn about an algorithm for division. So we're looking at the traditional ways, what your parents or families might call it, but we're talking about an algorithm. An algorithm is a way you can solve something every single time and it'll work. So it's proven to be true and we can use it every time we divide numbers. It's not just going to work part of the time. It's the way we always are going to divide. So we're going to show the algorithm here on this problem, and then we can use it with division, with decimals as well. So the problem we're going to start with, make sure your books are out, you're on page 169 and you are following along. On Monday, a board game factory made 25,650 game pieces. The game pieces are put into packages of 6 pieces each. How many packages of game pieces does the factory make on Monday? So with this problem, we're looking at 25,650 game pieces, a lot of game pieces. And we're talking about what to do with these game pieces. Well, they take all these game pieces and they're put in 6 in a bag. So we could draw groups of 6 till we get up to 25,650. That's not the most efficient way. Will it work? Yeah, you might be done in a 12-hour period. It would work, but we're going to talk about efficiency here. So we're going to start with the division algorithm, and I'm going to model it for you. If you can remember it from last year or from in the past, go ahead and pause the video, try it, and then come back and see if you were correct or where your errors were. So we're going to start with our dividend. Our dividend is what amount we start with. So in this case, we are starting with 25,650. Our divisor is how many groups we need. So our divisor in this case is 6. So dividend divisor. And our answer is going to be our quotient. So dividend divisor quotient. So if you want to think of it more traditional even, dividend divisor quotient. Okay. So we're going to think about what are we starting with here? We're starting with, and I'm going to move it down here, but we're starting with 25,650. And remember, we're putting them in those groups of 6. So our dividend is 25,650. We're dividing it, our divisor, by 6 to get our quotient. And when we're talking about this algorithm, we're talking about taking the 6 and seeing how it fits into each place value, each group. So first thing we're going to look at, we're going to take the 6 into the 2. Does 6 go into 2? Not whole number, or not even with leftovers. You'll get a fractional or decimal amount. So we're going to move over. Does 6 go into 25? Yeah, with leftovers, which is fine. What gets us close to 25? Well, 6 times 3 is 18. 6 times 4 is 24. So we put the groups. We're going to have 4 groups of 6 and 25. So 4 times 6 is 24. We're going to subtract. I'm going to have 1 left over with a 0. Okay, so one more time. We took our divisor. We looked at it. 6 does not go into 2 without being a decimal or fractional answer, but it does go into 25, and it goes in there 4 times. So 6 times 4 is 24. 1 left over. I'm going to bring down my next number. Does 6 go into 16 evenly? No, but we know 6 times 2 is 12. 6 times 3 is 18. So we know it's 2. We can't go over. 6 times 2 is 12. Subtract, you're down to 4. Next number comes down. We're going to use every single number here. Now we're looking, how many groups of 6 get us close to 45? Well, 6 times 6 is 36. 6 times 7 is 42. So 6 times 7 is 42. 3 left over. I'm going to bring my last digit down, which gives me a 0. 6 times what is 30, or gets close to? 6 times 5, which is 30. I'm going to subtract, get 0. I've used all my numbers. I have nothing left over. So going back to my problem, oops, apologize for that. They're asking how many groups of 6 can I make? I can make 4,275 packages of 6. So this would be my answer. And I did that by seeing how many 6s were in 25,650. There were 4,275 groups of 6. Okay. So we are actually going to skip over page 170. We're going to skip through 171, and we're going to look at 172 together. So we're on page 172, still in Lesson 8, Session 1. This is another whole number division problem. So we're going to do another practice problem together before we get into Session 2 and we start adding those decimals in. So we need some more practice with the whole number piece. So a factory receives an order for 94,500 tennis balls for a major U.S. tournament. 3 tennis balls are packed into each can. How many cans of tennis balls does the factory pack for the order? So looking at this kind of problem here, we're looking at 94,500. That's going to be our dividend. So we're looking at our dividend. Okay, and we're trying to figure out how many groups of 3 are there? 3 is our divisor to get our quotient. So remember, our dividend goes underneath the bar. Our divisor goes on the outside. And we're going to start dividing. So 3. How many groups of 3 are in 9? 3. So I'm going to do 3 times 3 is 9. And subtract, bring down my next digit. How many times does 3 go into 4? 1. 3 times 1. Okay, so I'm going to bring down my 4, which I got here. We said 3 times 1 is 3. Subtract, I have 1 left over. Bringing down my 5. How many times does 3 go into 15? 5 times. 3 times 5 is 15. This is where it's something new. We're going to bring down our 0. We have to use that digit. Does 3 go into 0? No. 3 times 0 is 0. Subtract is 0. Bring down my next 0. 3 go into 0? Nope. Bring down. We've used all of our digits. So we can make 31,500 packages of 3. Okay, cans of 3 tennis balls. So how many cans of tennis balls does the factory pack for the order? The quotient is 31,500. We know that because we saw how many groups of 3 were 94,500. Okay, so checking on the next piece here, how can we actually check our answer? So if we had this problem and I ask you, how can you see if you're correct or not without a calculator? We can take our answer, which was 31,500. We can multiply it by 3. We're working backwards. So this should give us our original dividend. So remember, we're trying to make sure we have 94,500 as our answer. So we're going to multiply like we did in Lesson 7. 3 times 0 is 0. 3 times 0 is 0. 3 times 5 is 15. Carry the 1. 3 times 1 is 3 plus 1 is 4. 3 times 3 is 9. Count my 3 places. 94,500. That matches my initial dividend, so I know my problem is correct. Okay, so this is just whole number division. This is the standard algorithm. This is the algorithm that is probably most efficient moving forward, especially with decimals. So we're going to use this algorithm on Session 8 problems. So if you go